Before we get started making visualizations, we should just review some concepts and terminology about data itself. Recall that in R, a table of data is stored in something called a data frame. We can assign those data frames to variables. And let's suppose that we have a data frame of information about cars that's stored in a variable called df. In this case, each row of this data frame represents something, in this case, a particular model of car. The columns of data frames contain measurements of some attribute. We can also refer to columns as variables, which are not to be confused with the variables within the R programming language. The other thing to remember is that a data frame column is essentially just a vector, and we can extract it using the dollar operator. Now, it's helpful to classify different types of variables by the type of data that they can contain. So one common classification is continuous variables. These contain numbers that can take on any value, including any value between any of those two values. In other words, you can keep on having decimal numbers with more and more decimal places between any 2 points, right? You could have 1 and 2, you could also have 1.5, then you could have a point between 1 and 1.5, so you could have 1.25, and so on. Another type of numerical variable is a discrete variable. In this case, we still have numbers, but those numbers take on particular values and not the values between those values. For example, we could have the number of cylinders in a car. Well, you could have a car with 4 cylinders, and car cylinders tend to be even numbers, but let's imagine we could have a 5-cylinder car. You couldn't have 4.5 cylinders, right? A car needs to have a whole number of cylinders. So this would be a discrete variable. We can also have categorical variables. These are ones in which we have distinct groups, kind of like discrete variables, right? They're distinct values. But with categorical variables, there's no numerical information attached to them. So, for example, we can have the make of a car. Here we have Toyotas and Ferraris. In this case, not only is there no numerical information, but there's no real ordering, right? There's no reason to think of one make of car before or after another make of car. An alternative is this column at the end, highlighted in red, the desirability column, where we have categories like low, moderate, and high. Again, these are categorical, but now there is actually an ordering to this. So we can distinguish categorical variables into those which are ordinal when they have some sort of inherent order to the categories, and non-ordinal where there's no ordering to the categories themselves. The reason it's important to bear in mind these distinctions is because it influences what type of graph we can create. If we have a categorical variable, it's natural to plot those values in a bar graph, like you see here on the left. Whereas if we were to plot just a single column of continuous data, then we would get a histogram like we see on the right. So two different types of graphs depending on the type of data that we have.